All right. Sometimes the answer for a given question that we're after is not easy for us to measure. However, there might be something else that we can measure that relates to that answer. And this means that they have different units, but they relate to each other, and we can analyze these units and identify the answer we're after from other measurements. We call this dimensional analysis or unit analysis. And this is an important critical tool that you need to be able to cultivate because um, sometimes we get so used to thinking that the answers to questions are found on the internet or found from our own wisdom or our experience, where in reality the answers are often something that we need to derive from values that exist out there, but we don't know them yet. So to illustrate this, I'm going to tell you a joke, okay? Um, Here is a joke about three people who were in the desert, all right? One person in the desert brought a gallon of water to keep them cool. The other person brought ice. And the third person brought a car door.
I know this joke.
Oh, you know this joke, do you?
Yeah, I do.
Is it a good joke?
No, it's not a good joke.
Okay, well, you tell us the answer, or tell us the punchline.
Well, the person who brought the car door was going to roll the window down when it get hot.
Okay, that's right. They roll the window down when it's going to get hot. That's why they brought the car door, and that's funny, right?
No, it's not funny.
Well, it's not funny to you because you already know the joke, right? But it doesn't make you smart because you already knew the joke. It just means you already heard the joke before, all right? So if I ask you a question, a scientific question, and you know the answer because somebody already told you, that doesn't mean that you're smart. All right? That's not the definition of intelligence. Intelligence isn't just regurgitation of numbers or answers that somebody told us a few moments ago. Intelligence is manifested when you come up against a question that you've never seen before, and yet you have the ability to answer it. And that's how we answer questions in chemistry and throughout the world of science using dimensional analysis. Okay? So a lot of people fight against using dimensional analysis. They say, "Oh, I don't understand why we're using it. That's too much effort for just an answer that I already know the question, a question that I already know the answer to." Well, if you learn dimensional analysis, you can begin to answer questions that you've never experienced or never been exposed to before, and that's where you want to be. There's very little value in being able to know the answer to a question that everybody else knows or is out there on the internet. That's not helpful. We need to have the ability to answer questions that we've never seen before. And so that's what we're teaching. We teach dimensional analysis for a long time in this class to answer questions that you already know the answer to, because that's how you learn to use the dimensional analysis. But you have to use the dimensional analysis. Many of you will fight against it and say, no, I don't want to use the dimensional analysis. I just know this. I remember that value. I just know that value. But that won't last very long. And sometimes people say, I'm not good at chemistry because I don't remember these specific things. And that's not the point. The point isn't to have a knowledge base that somebody can draw on a huge memory, because then only about three of us would be good at chemistry, right? The point is to apply the technique of dimensional analysis to many different scenarios. And once we're good at the technique, then we can begin to answer questions that we've never seen before. Okay? So let's introduce you to dimensional analysis. The major tool in dimensional analysis is what we call conversion factors. Conversion factors. Now, conversion factors are all just basically the number one. And what happens if you multiply a value times 1.
Is that a question for me?
Yeah, what happens if you take some value, let's say 12.7, and multiply it by 1?
Well, you get 12.7.
That's right. Any number times 1 just equals the same number. All right? So when we can find conversion factors that are expressions of different dimensions, but they are equal to each other, then we can say that that number is 1. So for example, 2 over 2 is 1, 3 over 3 is 1, 6 over 6 is 1, 3.45, 3 over 3.5453 is 1. All these are 1. What about 1 over 12? Is 1 over 12 1?
No, 1 over 12 is not 1.
Well, what if it was 1 foot over 12 inches?
Well, I don't know. Is that 1?
Well, it is because these are the same values. So I can use this as what we call a conversion factor to convert either foot to inches or inches to feet. All right? So for example, if I said I have a measurement that's 73.0 inches, all right, and I want to know how many feet that 73.0 inches are.
You just divide by 12.
Okay, now that's an example of using your own experience to answer the question. You've heard the joke before, you know what to do. But using the dimensional analysis would be to take a conversion factor that has inches on the bottom and feet on top. The conversion factor is a quotient, meaning there's a numerator and a denominator, that have values that are, amounts that are equal to each other, different values, different units, but amounts that are equal to each other. 1 foot is equivalent to 12 inches. If I take 73 times 1 divided by 12, that will give me my answer here, right? 73 times 1 divided by 12. And again, most of you recognize that you don't need to put the times 1 in there. So 6.083. How many significant digits here am I going to have?
1 foot, just 1 because there's only 1 in that 1 foot.
Well, remember, this here is a definition. This is a definition, so it's not going to limit my number of significant digits. I start with 3, so I need to have 3 significant digits in the end, so it's going to be 6.08. 6.08 feet. That's how many feet are in 70.3 or 73.0 inches. All right, so let's do that again, but this time let's think of it in terms of feet. If I have 275.1 feet and I want to know how many inches there are, notice how I've written what I start with here. I write my units of what I'm after there. We can also write a line that extends like this. And I can go from, I know I want to go from feet to inches. I can write in here my conversion factor. This time I want feet on the bottom because I need to get rid of the feet and I need to be in inches. When you multiply units by each other, it's the same way. Feet divided by feet cancels out and they're gone, and inches is left over. The conversion factor numbers is all I need here now. I need to know how many feet there are in an inch, or how many inches there are in feet. 1 foot, 12 inches, right? So then I can see that I need to take 275.1 times 12, and that'll tell me how many inches there are there. So 275.1 times 12, that is 3,301.2. How many significant digits?
275.1 has 4.
That's right. So I need 4. So it's going to be 3,301 inches. That's how many inches I have in that many feet. All right. So again, we do the exact same problem, but down below it just slightly. I want to know how many inches there are. So I write my units. I write an equal sign. I write my units. I draw a line out like this. I write the value that is provided and the units that are provided. And then here is where my conversion factor goes. I know the units of conversion factor have to have the same units down below, so they're gone, and then inches up top. And then I can write in the value here, making sure that when I'm done, I see that this makes sense. Because sometimes people will say, oh, 1 to 12, like that, right? And they make a mistake. And they say, oh, it's not 12 feet per 1 inch, it's 12 inches per 1 foot, right? Okay, very good. So this is what we're going to practice. We're going to get good at using dimensional analysis. Don't throw dimensional analysis away and say, I don't need it because I already know the answer. You just divide by 12. You just multiply by 365 or divide by 60 or whatever. You want to be able to learn the tool, and we'll learn the tool with questions that we've seen before so that we become comfortable with the tool. And then once we're comfortable with the tool, it will allow us to answer questions that we've never seen before. It's a very valuable ability. So stick with it. Don't try to just use your own wisdom and experience because it will run out. But if you learn dimensional analysis, you'll be able to apply it to a lot of different things. Okay, so where's my mouse? There it is. Found it. All right, so here is an example of a conversion factor between centimeters and inches. There's 2.54 centimeters for every inch. So I get out of that 2 different conversion factors. 2.54 over 1 centimeters per inch, or 1 inch over 2.54 centimeters, right? Multiple conversion factors from one expression. So here are a bunch of conversion factors. One of these conversion factors out here is not correct. All right, is not a true statement. Can you find it, Fred?
Not yet, no.
Well, keep looking, see if you can find it. You at home look too, see if you can find it.
How am I supposed to know?
Well, this one, is that true? Is 12 inches 1 foot?
Yeah,
Is 1 foot 12 inches?
yeah,
Is 1,000 liters a milliliter?
I guess so.
All right, keep looking at these and see if any of these are not true. 2.54 centimeters for every inch?
I think that one's right.
Okay,
Wait, that one's not right.
which one?
The 1,000 liters in 1 milliliter.
What's wrong with it?
There's 1,000 milliliters per liter.
Very good, that's right. This one is not a correct conversion factor. There's 1,000 milliliters for every liter, not 1,000 liters per milliliter. Do you think that's a way that students commonly make mistakes when they're doing calculations?
Oh, I guess probably so, huh?
Yes, that's right. Those conversion factors, you have to pay close attention to them. Okay, so here's another example. If we're going to convert 34 inches to centimeters, we start with our units. We write it down like this in math. What we do is we say our equal sign. We draw a line. We write the units we're after, centimeters. We write the value in the units we have, 34 inches. And then we set that up. See, all of that was free. It didn't require any understanding of anything. The units we're after, the units we start with, the value they gave us. Set it up so we can clearly see it. And then we have to put in here some information. We know that the inches need to go away, so we're going to divide out the inches. We need centimeters on top, and now we need a conversion factor. And this is where you can go to Google and find out how many centimeters there are in an inch. 2.54 centimeters per inch. I mean, we were just talking about it, right? So 34 times the 2.54 divided by 1 should tell us how many centimeters. Okay, now here's another one. I can't go on the big kid rides at Euro Disney until I reach 1.1 meters, but I don't know how many feet that is. How many feet is that? All right, so we do the same thing. We set up our dimensional analysis by writing an equal sign. To the right of the equal sign goes the units that we're after, and we draw a line here, and we start with the units and value that we're given. So what are the units that we're after?
You want it in feet.
That's right, we want it in feet. Now you can identify that because you read through the problem carefully and identify what they're after. What value do we start with?
1.1 meters.
That's right, 1.1 meters. And now I have to find a conversion factor. The conversion factors don't need to be fancy. You don't need to go online and say, I mean, if you were just to ask Google 1.1 meters to feet, it would tell you. That's not a big deal. But we want to, again, learn how to use our dimensional analysis to figure this out. The conversion factor that I want to choose has to have what units down here?
I don't know. How can we tell?
Oh, because we see that we started with meters and we need to get rid of meters, right? Do you know anything that we can convert meters into?
Meters can go into centimeters.
Very good, centimeters. Meters to centimeters. For every meter, how many centimeters?
Is it 1,000?
Centa means what?
Oh, it's 100, 100.
That's right. Centa refers to century, hundreds. So 1 meter, centimeters. I'm still not at feet. How can I get to feet?
Now you can go to inches.
That's right. We know centimeters and inches. We were just playing that game. So how do we do that?
1 inch, 2.54 centimeters.
Very good. 1 inch, 2.54 centimeters. Now what?
Now you can go to feet from inches.
Very good. Inches to feet. So it's 12 to 1, like that?
Yeah. Oh, wait, no, that's wrong. 12, 1 over 12.
Very good. 1 foot is 12 inches. Now, to solve this problem in our calculator, we just, let's scoot this over a little bit here. Give me some space for my calculator. We just take our 1.1, multiply everything at the top. So times 100, times 1, times 1, divide by everything at the bottom. Divide by 1, divided by 2.54, divided by 12, and I get 3.6. How many significant digits should I have?
2.
Yeah, 2 significant digits because I started with 2 here, so 3.6 feet. Okay, very good. So I identify the units I'm after. I write an equal sign. I draw a long line like this. I bring in I identify the units I'm starting with. I bring in the appropriate conversion factors, do the math, and get the answer. Okay, good stuff. So here's an opportunity for you. There's a conversion factor. There's a number. We want specific units. All right. See if you can get the answer. All right. Now, the numerical answer is not nearly as important as the dimensional analysis schematic that's going to lead us to the numerical answer. So you work with this one and get that dimensional analysis schematic. If you get the right number, that's good too, but the dimensional analysis is necessary, not just the right answer. All right, how would you do this one, Fred?
What do we do first?
You write an equal sign. Remember, you write an equal sign and you draw a line. That's always a good way to start a problem. It helps you feel empowered. Okay? What goes to the right of the equal sign?
Well, we're looking for kilometers, km.
That's right. I would like to know how many kilometers there are. In what? What unit am I starting with?
25 feet.
25 feet. Very good. There we go. We got it. We have a setup for us to use our dimensional analysis and to look at the units, and that's why we call it unit analysis. We can analyze the units and know what has to happen here. I need feet on the bottom. I know inches, right? I don't need to get complex. Inches, I know to centimeters. Centimeters, I know to meters. And meters, I know to kilometers, because kilo means 1,000. So there's 1,000 meters for kilometer. How about meters and centimeters? What's that?
That's 100.
100 over 1?
Let's see. No, 1 over 100.
Very good. 1 meter, 100 centimeters. How about this one?
2.54 over 1.
That's right. There's 2.54 centimeters for every inch. How about this one?
12 over 1.
Very good. 12 over 1. So 25, what do I do with the 12?
Times 12 times 2.54 times 1 divided by 1. You can leave those out, right?
Yeah, you don't need to do the ones, right? Because we know what the answer is. So 25 times 12 times 2.54, then what?
Divide by 100, divided by 1,000.
Very good. So let's see if we can do that in our computer and get an answer, or our calculator here, get an answer. 25 times 12 times 2.54 divided by 100 divided by, divided by 1,000 equals, oh, what happened? 25 times 12 times 2.54 divided by 100 divided by 1,000. 0.00762.
So is it A?
How many significant digits should I have?
2.
All right, so 0.0076, 0.0076 kilometers.
700, no. 7.6. Oh, I don't think it's any of these.
I think you're right. 7.6 times 10 to the minus 3. 1, 2, 3, right? If we're going to write that in scientific notation. Okay. 7.6, the number between 1 and 10, and then the number of significant times that the decimal point is going to move to the left times 10 to the minus 3. That's scientific notation. Okay, very good.